Hello, and welcome to Linux, the operating system of the people. My name is Aaron Rosenmund. I own and operate IamIroncat.com and use that pen name to publish tutorials, blogs, and other content relevant to cybersecurity. Professionally, I'm a full-time cybersecurity author for Pluralsight doing security research and creating content with a focus on incident response. In this short tutorial, meant for people brand new to the concept of Linux as an operating system, I will be providing you with an overview of the history of Linux, what it means to be a file-based operating system, as well as walking you through the actual loading up of Ubuntu, a Debian-based distribution of Linux, and subsequently using that system to complete basic configurations and tasks like internet device configuration, file browsing, reading files, creating files, accessing content on the web, as well as application management. The story of Linux begins with the creation of Unix. Unix was created out of the frustration of Bell Lab engineers while working on a combined project called Multics. After pulling out of the project, a group of the engineers created their own OS based on hierarchical file system. In the common components we now expect from a Unix system such as device files, command line interpreter, compilers, and processes. This of course was a proprietary system, and the true onset of Linux that is freely consumable and open source was created in 1991 by Linus Torvalds as a student project, based on Unix by way of a OS called Minix that was not freely available for distribution, but the source code was available. Minix was written to supplement a textbook released by Andrew S. Tannenbaum for 16-bit hardware and was not well adapted to the new 32-bit architecture that had been released. After writing a new kernel optimized for 32-bit hardware, Linus posted the OS to a Minix users news group. The rest is, well, history. This now fully available and freely distributable OS distribution has taken off, and variant projects have taken it even further. Common distributions now include Ubuntu, Arch Linux, Fedora, CentOS, Tails, Linux Mint, Kali, and more. All of these are based on one of two main distributions, Debian or RPM, and all have different implementations and variations. Some with specialized purposes like Tails, which was created as a privacy distribution, and Kali Linux, which is customized and preloaded for pen testing activities. As I said, the first thing we're going to go over is the hierarchical file system that was originally conceptualized with Unix and then built on with Linus's open source and freely distributable Linux. So the common level directories that you need to be aware of and may interact with as a normal user include and start with root. So which just looks like a /. This is going to be the beginning of the file system on any Linux system, including Unix. Underneath this, kind of in a tree root type manner, include bin, etc, home, opt, temp, user, and var. Different systems and different distributions have different folders available that are used in different ways. Again, these are kind of like guidelines more than rules, but these are some of the common ones. So bin contains binaries and other executable programs. Programs are written in source code, and the source code is human-readable text, generally going to be in C or C++. These text files are then compiled into machine-readable binaries. They are called binaries because machine code is a string of zeros and ones. Applications that you can run are sometimes located in /bin. /etc, or etc, includes system configuration files. Configuration files control how the operating system or applications behave. For example, there is a configuration file in /etc that tells the operating system whether to boot into a text mode or a graphical mode. /home includes the home directories. Linux systems can and often do have multiple users, and the home directory is where you can separate your data from another account's data. For example, a user Jeffrey's home directory is /home_Jeffrey. You could store documents or music files or pictures. /opt is for optional third-party software. OPT is for software that is not bundled with the operating system. For example, Google Earth is not part of the standard Linux operating system, so Google Earth gets installed in OPT. /temp is temporary space typically cleared on reboot. Most of the Linux distributions clear temp at boot time. Therefore, if you put files in /temp and the Linux system is rebooted, your file will be gone. /temp is a great place to store temporary files, but do not put anything in /temp that you want to keep long term. /usr, called user, where the user-related programs live. /var, standing for variable data, contains most notably the log files. Things that change often on a Linux system are typically log files that are generated either by the operating system itself or other applications. In Linux, people typically call these containers directories. In other operating systems, people call the similar concept folders. So enough of that. We are now going to move into loading up a Linux hierarchical file system called Ubuntu. All right, so check it out. We're going to install Ubuntu, and a really great way to check Ubuntu out, which is a Debian Linux distribution, is to go ahead and use Workstation, a VMware product. And if you want to use Player, you can also do that. I'm sure there's places you can download a already created virtual machine of Ubuntu, but we're going to use this. I already have a whole bunch of them. Look at that. Ubuntu's right here, right? So I should be able to spin an Ubuntu up pretty quick. So I'm going to make a new virtual machine. One of the great things about Ubuntu is it doesn't really need a whole bunch of stuff. I'm actually going to go custom because I just want to display that a little bit. Yep, we're going to make this for Workstation 12 because that's what I have. We have a disk image here. That is Security Onion, which, go figure, is actually a Ubuntu distribution. I'm going to look through and see what kind of ISOs I got on my stuff. No, it's probably going to be a program store, huh? Where's my program store? Program store, ISOs. Check you out. Here's Ubuntu. So we're going to go ahead and install Ubuntu 17.10. It's not the most recent one. But it's recent enough. Good, I went ahead and detect it. We're going to call this Ubuntu 1. Let's make a username. Let's call it username tstark, because you know why. And the password is a secret. Don't tell anyone this password. Never, ever. I already have one called that, so let's call this -1, or new. What do you think? I'm going to go ahead and let that store on my main storage, but you could change where the files are stored. So one processor, that's a little slow. I'm going to make it 2. We'll leave it at 1, so that actually gives it 2 cores. That's also a little slow. Let's give this thing 4 gigabytes because we can. And this makes everything go a little faster for us. Network address translation. So when you're making a virtual machine, this isn't a virtual machine course, but you can make it where there's an internal network that gives out its own IP address space. So you're then connected to another internal network, which would be your Wi-Fi or your local network. That then in turn connects to a public IP that your ISP gives you, and that's how you get out to the internet. All this recommended stuff is the way to go. And we will create a new virtual disk. We don't need very much space. And I like to just make it one file because that just makes it easy. There we go. And that's it. And I want you to go ahead and do that. So there it goes. It's creating the virtual machine. This should go pretty quick. It's now spinning up. So let's go full screen. And there's the Ubuntu loading screen. Booted from that ISO as if it was in the CD drive. That was a pretty cool little Ubuntu noise, and it's saying I'm installing. So there it goes. We still literally haven't clicked anything. All we've done is turn it on. It's handling everything itself, which is pretty great. It's creating a file system. And we're now in the installer. Gives you a little update and preview of the features. I think 17 is something aardvark. Just a guess here based on the graphics. It's probably likely. Ooh, even more software. Ubuntu, now with more software. Your music. Watch out, iTunes. You can do fun things with photos. Who knew? You can make the most of the web with things like Flash. Don't use Flash. Yeah, there you go, LibreOffice. Who needs some paid Microsoft Office stuff when you got LibreOffice, right? Access for everybody. That's important though. I like that. So we're just waiting for these files to be copied and then you can get ready to install. So it's going to take a minute. Also notice at this point, we've already started downloading language packs. So where's it downloading it from? It's downloading it from the internet. And it has connected without any configuration to the internet that was already connected via that NAT translation we talked about earlier on this virtual machine. So if you're setting this up on a bare metal situation, you're gonna have to, it's gonna ask you for that information. You'll have to set it up yourself. But because this is already set up, it already has IP address, it's good to go. It's not making you do any additional configuration. Okay, so we've reached the conclusion here of the install, and it is automatically rebooting itself. One of the cool things I like to see is when it installs Open VM tools, and here we are ready to log in with the username of Ubuntu-1 and the password of secret, don't tell nobody ever. So we log in. Congratulations to me. I actually remember the password first try. And now we're going to get into the desktop environment called GNOME. And that was really easy, right? So next, let's go ahead and migrate into some of the basic features. So we're in the GNOME desktop, which is a package that's loaded that gives a graphical user interface to the background kernel. And there's also, of course, in true Linux style, a terminal through which you can interact with different systems. as well. Okay, so you're new to Ubuntu, and we just installed this, and the first thing that I think you should notice is that I didn't click a single button, and everything installed itself. It's also looking at updated software since it has been issued since 17.10 was released, which is the ISO I installed it from, and saying, do you want to go ahead and download this? And that's that app manager handling that for you. This is a GUI component that's letting you know what's going on, so you don't have to delve into the console unless you want to, right? And there it is. Ubuntu is pretty good. You can't log in as a root user. You have to have a user account, and then it's going to ask you for your sudo privileges or your admin privileges. So it's going to go install some of those updates. It's mainly some libraries. And what you'll notice first also is that if I want to look at all my applications, kind of like looking at my start menu, here's all my applications. Very cool. I can search through them as I like. There's also this bar with a whole bunch of hot menu applications. So if I want to get out of that, I can go into activities up here. I can see anything that's been going on. There's nothing going on right now. And if you see when I click that, there's actually this drop down over here. I can have multiple desktops kind of by nature, which is included with other OSs now as well. If I want to use the console, I can also use the terminal. Just open the terminal, right click open terminal. And I have that available for me as well. And I can use all the commands that I need to here as an experienced Linux user. So as we said, networking is important. It seems to already be connected because it's part of a VM. And that was connected to the NAT VMnet, which is great. But let's also look at these wired settings in the GUI here that it provides us. So it shows us that we're connected. So we're sitting here in our network stuff, and we can take a look at those available configuration settings, right? So there's our IPv4 address, our hardware address, and IPv6 address it has as well, which is pretty interesting. Those probably all given out by DHCP since it says connect automatically, right? So if we go and open up the terminal, how can we look at that configuration in there? Well, we can use the command IP address, and it'll show us LO, which is the loopback address, but also show us this ENS33, which is the interface by which it's connecting to the internet. So that's where you can see that there. And it's also part of a configuration file in the file system. So if we want to just browse the file system from here, like we talked about, we can use a command called ls, and that'll list any files in the current directory, which is our current working directory, is home tstark. So we made tstark as a user, and that user has created a folder underneath the home folders, just like we talked about. And if we want to look at the root folder, we can just use the change directory command, which is cd, and change directory to root, and then use ls, which will list our directory, and we'll see what's inside of it. And here's a lot of the same folders or directories that we talked about in the standard directories, as well as quite a few more, right? Like sys. So if we cd in the sys, this is how we're kind of navigating through the system. We can see like, oh look, sys has some of our kernel stuff and our devices. So what's inside devices? As you can see, there's also a bit of a coloring deal going on with the console. So anything that's blue is a directory, anything that's white is a file. So then we can change into, you know, the system directory. And what do we see in here? This is CPU stuff, so this starts getting interesting. What else can we see? Clock events, that makes sense. I'm curious to see what's in vulnerabilities. Meltdown, Spectre, bypass, though this is kind of cool, right? So, you know, everything in here that we need to know about. Let's talk about V1. Shows a mitigation. So this is pretty cool. This is how this file system is used and navigated. Naturally, as we were going through here, we used cat to read a file, like the Spectre file. But if we went back to a file that was like bigger than that, like maybe let's go look at some logs, right? Which is inside the var folder. And inside var, maybe go to log. Inside log, we can go to the kern log, right? There's a whole bunch of stuff here. And then see how we talked about it lists out really quickly. And you can't see the top, right? So it lists from the top to the bottom and just kind of streams. But if you want, you can use more. And that's going to give you the option to look at the top of this and then kind of tab through each page so you're not missing anything. Okay, so you can control C out of that. And another thing that does something very similar is the less command, because less is more, right? So less actually came after more and does kind of the same idea, right? Which is different capabilities. You see that colon there kind of looking a lot like VI. So if we can read files, that's pretty cool. I just talked about VI. Let's talk about how we make some files. So I am pretty positive that we can probably find LibreOffice on here. It's not installed. Let's see. Well, there's LibreCalc. So Libre Word document, we can use the GUI here. It's got an application. Kind of looks a lot like Word, right? And we can save this file, say, hi, I'm a file. We can save this to our desktop. All starting to feel really familiar and easy to do. or into documents, right? We'll call it untitled, because then the next one will be untitled new, and then untitled new. And now if we go browse through those files with the GUI, the same way we could anything else, we'll go to our documents, and there's an untitled file, right? And in the same way, we can go to home, tstark, documents, and we'll see that same file. But if we want to create a file from the command line, there's ways to do that as well. We can launch the LibreOffice document creator, but that's not as much fun as using something like echo, hi, I'm a file, into a actual file, right? So file1.txt. Cool. And so when we look inside here, we also see that, and we can use cat to read that file. It says I'm a file, right? So here's nano. Another way to create a file, say I am also a file, right? And this one has its own controls, the same way VI and Vim do. With the file name, so what do you want the file name to be? File new. There we are, and if we look inside there, there's our file new that we made. It's just in the current working directory because we changed consoles, brought it back up, put us in our home folder. So if we look in here, we get the file new that we just created with nano, and if we want to copy that somewhere, start playing around with these, we can file new that to document. So it's sitting there living with the rest of our stuff, right? So now if we go ahead and ls, and by the way, you can ls without changing directory, you can see file new's in there. Now if we don't want it in there anymore, we want it to go somewhere else, we can do the move command and say documents, file new needs to move to just home. Let's try that. Oh yeah, see, we don't have permission. So it's a cool thing about Ubuntu is it makes sure that you're using the proper permissions. And now we did do that. Let's look inside home, and there's file new. So that's how you copy and move files around the system. So just like everything else, let's get ourselves a new clear terminal here. Just like everything else, there's a GUI and a terminal or console way of doing it. If we want to access the internet to get to our Facebooks or whatever else we need, so we can get our chicken tendies, we can go here and look at that. Facebook's actually already saved as a link. So we can go ahead and go to Facebook here, and that's just using Firefox that's loaded as application, just like it would be on any other OS, right? So this is no different from Mac OS or Windows PC. But if you want to do it in a console, there's ways to do that too. So let's take a look at the console method. Curl is one way of doing it. There's a whole bunch of other ways. You can use Python using the post and get package. But curl will also get us it'll do a get request wherever we tell it to. So we tell it to do facebook.com. Oh, curl is not installed. If curl is not installed, right, but it really just is not found. So what does that mean? Well, that leads us right into our application installation methodology here. So as opposed to downloading executables and running through an install package, you can do something similar in Linux. You can download source files, compile those source files from C, and then install those things. But there's also a package manager that allows you to do stuff pretty easy here. So the one on Debian installations is aptitude. So you can do apt-get install, and we can just say curl, because we know that curl is something we want. It's not allowed because it has to be sudo, and there it goes. And now it's resolving dependencies for us because it needed some extra stuff, and it's installing curl. So now let's use curl on something like Google and see what comes back. Okay, and what we're going to get back is the HTML code that would return in the first place when we do a GET request. So you can access the web through a normal browser. You can use the terminal and do something like curl to get the text interpretation of that web page as well. So as you can see, it's really easy to use Ubuntu as almost a drag and drop replacement for Windows and a lot of the functions that it can do. I didn't have to install anything at all. I simply put the ISO in the CD drive and it installed itself, rebooted, and gave me a login. When I logged in, I was able to do almost anything I needed to do normal at the bat. And so I hope this got you started on using Ubuntu or any Linux. Really, a lot of these concepts apply across Linux, with the exception of the package manager. If you're using an RPM distribution like CentOS, you have to use RPM install or yum, but the concepts are the same. So if you want to get started using Linux, I recommend doing it ASAP. And there's a lot of open source tools that Linux allows you to use because they're made for Linux that can really increase your productivity depending on your profession. Thanks for watching.